Hello my dear students, welcome to this next video. In this video we are going to talk about a problem which was asked in GATE 2019. It is related to real analysis. It is an interesting problem. Let us do it. So let us first read the statement. Let R be the region in xy plane bounded by the curves y is equal to x square and y is equal to 4x square, and then xy is equal to 1 and xy is equal to 5. Then the value of the integral is equal to what? So this is the question, right? So now you see, if you look at this problem, so we know that we are going to do double integration here, and let us make the diagram first. So if we make the diagram first, so you will make this these curves y is equal to x square and then y is equal to 4x square, then you make xy is equal to 1, this is a curve here, and then xy is equal to 5. So you can very clearly see that this area here, let me highlight it in yellow, this area is the area of integration, right. And if you look at this area carefully, you can see that there are multiple regions, like this region is bounded by two particular curves, then this is a separate region. So either if you want to work on this particular area and you want to double integration, you have to break your integral into three parts. So that is one way. What we can do is, you can just work on this particular integral here, and then you work on this part separately, then this part separately, and then this part separately. That is a good idea. That is not a very good idea. Why? Because lots of calculations will be there. So can you think of an alternative? So the answer is yes. You can look at the curves. So if you look at the curves, so these two curves are basically of the form y upon x square is equal to something, and these two curves are of the form xy is equal to something. Now if we look at here y upon x square, so this is y upon x square is 1 for this curve and y upon x square is 4 for this curve, and similarly xy equal to 1 to xy is equal to 5. So what we can do a transformation. So that is what I have done. So it is your choice what way you want to proceed. If you like lots of calculations, then you can go with the traditional way without the transformation, but I will recommend transformation. So here I have taken u is equal to xy and v is equal to y upon x square. So you can see that what we can do here is, when we do integration, like we do use the transformations, we have to calculate the Jacobian, right. So Jacobian of uv with respect to xy is ux uy vx vy. So what is the derivative of u with respect to x? That is y. That u derivative with respect to y is x, then v derivative with respect to x is minus 2y upon x cube, and v derivative with respect to y is 1 upon x square. So this is the Jacobian here, right. So once we have the Jacobian, so we can just you have to calculate the determinant here. So this is the Jacobian 3 y upon x square, which is actually 3v, right. So Jacobian we have calculated from uv to xy, but because our integral contains dx dy, so we need the Jacobian from xy to uv. So that will be just the reciprocal of whatever you have got here. So you have to do the reciprocal of 3v, so that is 1 by 3v, right. So that means this integral here will be transformed to 1 by 3v into du dv, like in place of dy dx we can write this, and upon, in place of y upon x square we have to see what you can write, and we also have to look at the region, right. Now let us look at the region first. In the ub plane, y is equal to x square means y upon x square is 1, so that is v equal to 1, and y is equal to 4x square means y upon x square is equal to 4, that is v is equal to 4. So we have v is equal to 1 to v is equal to 4, and then xy is equal to 1, that is u equal to 1, and then you have xy is equal to 5, that is u is equal to 5. So you have u is equal to 1 and u is equal to 5. So this is the region, this is the rectangle we get, right. And again you have this term of y square, integrand is y square upon x. So what I have done, y square upon x, we have written it as y upon x square into xy. So this is u and this is v, sorry, this is u and this is v. So this becomes uv, and in place of the dx dy term we get this, and then this is the region of integration. You see, with this transformation this becomes a very simple problem of integration. So this v cancels, so you have this v cancels, you have u upon 3 du dv. You can straightforward integrate, so you get u square by 6 1 to 5, then you have v 1 to 4. So you integrate simply, you put the values, you get 12. So this is your answer. So the answer to this particular problem is 12, right? And you have to understand that in this particular problem we have taken the help of transformation, right? So sometimes in integration transformations are very important. So you should know how to do the transformation when we are dealing with integral. So you have to have the knowledge of this Jacobian here. If you have any doubts, please write in the comment box. Thank you for watching this video. Please share this video with anybody who is preparing for GATE or NET examination. So you see this series now is having more than 100 videos, right? So you are solving more than 100 problems which are asked in the previous GATE years, right? So it's a very big advantage if you can complete this playlist, and please recommend it to your friends also. Please share this video and subscribe to this channel. Happy learning.